Welcome to the ZOOMTOWN Experiment. For today's video, we're going to cover a couple of topics. Our plan forward, and then the other topic will be powering up the Zoomie in its full assembly stage and testing out basic functionality. I'll cover that at the very end of the video, and we'll show you that. But for right now, I want to talk to you about the plan forward, how many steps we have ahead of us before we can actually start running the ZOOMTOWN experiment. And that would start with 5 zoomies. I'm going to go through this list. It'll be line by line, and these are rough categories or rough groupings of tasks that I need to do. So I'm not even sure how I'll present those videos yet, because I just simply need to do the work first and then figure out how to at least explain to you what happened in that phase of testing or development. So let's begin by going through this list. And the first item on the list is post-assembly basic functionality testing of 5 zoomies. And that, as I mentioned, we'll do at the end of this video. The next step is self-driving testing of each of the 5 zoomies. This is a very critical test as well. I've done numerous tests like this in the past where I had put the trip plan inside the Zoomie control program and had it execute a little trip. And on that trip, it might be going around a block, and it'll pull up to each driveway, drive into it, park, back out of the driveway, turn, and get going in the same direction again. And that really shook out a lot of problems with earlier versions of the Zoomie. So that's our next step. The next step is to get the scheduler program running again with basic functions. The scheduler program we don't talk a lot about historically, and we probably won't go into code details in the future either. If you would like for me to discuss all the code details for the scheduler program, let me know in the comments below, and I'll try to create something along the way. But the scheduler, its primary function is to basically manage the experiment. It runs a schedule of random events for a Zoomie to go from point A to point B, all random at random different times and random different places. It also has to manage some of the traffic control that has to go on as the zoomies are moving around. Each zoomie sends telemetry information back to the scheduler, and it uses that data, hopefully, to figure out how to keep the zoomies from crashing into each other. The trip plan generation, the data table, all this stuff is in that scheduler. So there's a lot of work I got to do in there, but I'll try to keep that out of the video sequences and so forth. Once I get that up and running, the next step is to update the geometry tables in the scheduler. There's a lot of changes I've done in there that are driven by the changes I've made in the Zoomie control program in how I want it to move and how each move needs to be designed, or defined, I guess is the better word. We're going to go through, or I'm going to go through and have to check that virtually every dimension, which we would call the digital version of ZOOMTOWN over here, is perfect match. Everything has to be very, very accurate between the data table and what reality is. That's going to take a lot of tedious work to get that all worked out. But once I've got that all done, that would set the stage for updating another of the geometry tables, which is part of the auto route planning thing. Now, we're using the Dijkstra algorithm to auto route from point A to point B, or start to finish for each Zoomie path. Well, that needs a specific set of data. It's not necessarily geometry specific, but it has to relate to it in an associative way. It's a very fascinating technology. And if needed, I'll go into more detail about that once we get it up and running again. But that's just another huge data table that I've got to nail down and get absolutely perfect. Once I got that foundational stuff together with those data tables, now I need to rewrite the code that does the trip plan generation. So much has changed in the Zoomie control program and how it reads the instructions of how to get to its destination, and I need to update the automatic generation of those instructions. Again, that's going to be a lot of tedious work, and I won't bore you with all the details on that one. Once I get to there, now we're starting to get into the really cool part, because now I'll be testing out generated trip plans. So the scheduler will generate the trip plan, the Zoomie will then execute it, and through testing there, hopefully everything goes well, or I have to make fixes and get it so that it does go well. To give you an idea of the level of testing that'll go on in there, I believe, if memory serves me right, and I wouldn't trust that very well, there's over 1,000 different combinations of starting at some point and ending at another point. That is a lot of testing, and I won't test every single one, but I have to test a substantial portion of that to make sure we can run the test without failures of that type. Once we get through that, it gets real fun, because now we're going to start running multiple Zoomies simultaneously. And that'll probably be manually triggered, primarily by me operating the software, sending out a Zoomie here, and then wait a little while and trigger another Zoomie to go, see how they interact, which will then help me to develop two critical portions of this that have only been touched on in early testing, but never fully developed. And that'll be development of collision avoidance routines and traffic control systems. I've got a four-way intersection here where all four Zoomies could collide together at the same time. We don't want that, so I've got to have traffic control systems in there. And that will be handled by the scheduler system running on that Raspberry Pi 500, and it's going to use telemetry data from the Zoomie, which is sent back in a continuous feed to the scheduler via MQTT communications. A lot of stuff is going to happen in that phase. That would be collision avoidance and the traffic control systems. The collision avoidance, it's got to be able to deal with different situations where one Zoomie could bump into another Zoomie. And that can be very simple, or it can be incredibly complex. I am strongly favoring doing it the simplistic way, because we're really running out of horsepower, so to speak, with the Pico as the brains for this little robot. Finally, once we get all that done, now we're into actually running the ZOOMTOWN experiment, and that'll be with the 5 Zoomies that we see right here. And from there, the experiment will expand based on results of the experiment, so to speak. So that's our plan forward, and that'll give you a rough idea of the different videos that I'll be putting out, and I can't assure you of any specific schedule. Right now, my world is a little more chaotic with my consulting business and some other activities going on, so I'll just do the best I can to keep them on a regular schedule. So with that out of the way, let's dive into the testing, and then we'll have a little more discussion after that. Now let's go ahead and dive into our first test on Zoomie number 1. Here's our layout. We've got the Zoomie. It's powered by the 18650 cells. It's powered up. It's connected to my umbilical cord, which is a USB cable back to Thani, so I can observe what's going on. The tests will be rather simple. I'll explain them as we do them. We'll start out with the first test, and that is just to observe what color the indicator LEDs are, and as they change color. So we'll run that test program. They're green, and then red. Both of them operated properly. How was that for an easy test and a quick one to pass? Next up, we'll get this over here in the middle somewhere. I am going to test the CAS system. So I'll use my hand as a block here, and if I get closer, the number should go up. Move away, the number should go down. And I'm not concerned about calibration of distance. That's not something I would control at this phase. So that test passed. Next up, we'll test our photoreflective sensors, the two sensors at the front, which are read as analog values. And we'll just take this card and we'll slide it under. I'll put it in this orientation. We get a little better reading. As we come in, we'll see the numbers change from side to side. Those are the analog values. We'll check the back photoreflective sensors, and these are TCRT 5000s. Now the back ones are operating in a digital mode. They are located here and here. So we'll just take our card and pass it underneath. We'll start here. We're on full black. Now the left sensor sees the white line. And now the right sensor sees the white line. And we'll just pass her on through, and it'll do it again with the narrower white stripe. So that passes the test. Next up is the one I got to be the most careful with, because the Zoomie will be moving in this test, and if things are wrong, it's going to go off in the wrong direction somewhere. So I'm just going to get this over here. Again, I'm not utilizing the white stripe here. It's just for a visual guide at this point. Now for this test, we'll be seeing the encoder feedback on the screen in the lower right-hand corner. And the Zoomie will make a turn, straighten out, make a turn in the opposite direction, straighten out, and then it'll drive forward a distance and then back. And we should see the encoder feedback show up at the bottom of the display. And that looks like another very successful test. I'll repeat this on the next 4 Zoomies. As you could see in that testing, it went pretty darn good. There were a couple of things that I still need to analyze yet, which is the great part about videotaping a lot of this. I can review that over and over again. But most everything performed as expected. The one red flag that worried me a little bit is that I know the motors that I've purchased are not identical pairs. I grouped them together as best I could by measuring the resistance of the motor, hoping that that would also help me to keep both wheels spinning at the same speed. Now, truthfully, that is actually handled by all the steering algorithms that are built into the Zoomie control program. But I need to get things as identical as possible. So I want to study that a little bit more. But for right now, I think we can call this phase of testing complete. So with that, I'm going to wrap up this video before it turns into an hour of jibber jabber. And I hope to see you again in the next video. Thanks so much for watching. See you again soon.
My daddy used to tell me, Son, you ain't had something. Oh no, son. Till a woman treats you good when you ain't got nothing.